Alright, we're approaching the end of this course, so let's recap what we've learned and then wrap up. Firstly, you learned about the three different approaches to writing software. There is a traditional development approach. That's the classic, write the code and then debug it until it works. It feels like this is how software should be developed, but it's got its problems. We tend to end up with overly messy and complex code, and we're missing a verification step where we can run some sort of automated tests, as in unit tests, and we will know whether or not the behavior of the code is what we expected or that expected behavior has been broken. We discovered there's also test after development, which is very much the traditional development approach with unit tests tacked on at the end. So we retain the advantages of the traditional software development approach where it kind of feels like the right way to go about it, and we've got unit tests that verify our code works as expected. Before we celebrate though, we haven't addressed the real problems of the traditional approach, which is this messy code, overly complex code. We've also got the problem where tests feel like make work at the end. We've done all the development, our code does what we expect it to do, it's got the behavior that we want, and now we just need to add tests on at the end. Yeah, whenever I've had that in the past, I didn't like it. Furthermore, the tests also feel optional. They're tacked on at the end, and when we've got deadline pressure, we may feel like we should drop the tests. Alright, and then finally there is test before development, also known as test-driven development, where we write the tests first and then we write our production or implementation code. One of the big advantages that TDD has in store for us is the result of minimal complexity and very clean code. We also have the verification step baked into the process. Unit tests are required before we get to write any implementation code. Verification is baked into the process. There are disadvantages. TDD is not a free lunch. If you've been developing software for a number of years, it will feel somewhat counterintuitive to start with, and there will be some time of low productivity when you're getting into it. You should count on a few weeks of initial low productivity. And TDD isn't so good for working with existing legacy code. So when it's already horrible, we need other techniques that I will explain in one of my other courses. It can be used for writing entirely new functions or methods in legacy code, but working with existing classes and that, not so good. We learned about unit tests and unit testing. Unit tests are these little automated bits of test code that verifies the behavior of a unit of work in a system. So small scope of work in a program. And just because they've got a small scope doesn't necessarily mean it's for a single class. Sometimes in a unit test, a number of classes are involved. And we found this with our shopping cart class. We didn't just have the shopping cart class, we also had the shopping cart items class, the product class, and there were a number of exception classes as well. Unit tests are very much meant to be restricted to in process. Okay, so we don't want to involve unit tests in connecting to a database or reading from a web service or even writing to the file system. This is not what unit tests are about. When we have to do those things, we will need to involve stubbing and mocking techniques that I will demonstrate in my next online course. Unit tests never have any I/O. And unit tests ought to be run automatically in a test harness or a unit testing framework. Examples of a unit testing framework is XUnit or older NUnit or MSTest. For unit tests, we want to follow a certain structure where we firstly arrange, then we act, and then we assert. Arrange, act, assert is very much what we end up doing with any kind of system, where we have an initial state, then we act on that state, and then we end up in a final state. Our arrangement is all about ending up in that initial state. Sometimes for a shopping cart that meant just creating a shopping cart. At other times it meant creating a shopping cart and then adding further product and quantity into it. Acting, depending on what we were doing with our shopping cart, it meant adding into the shopping cart, clearing out the shopping cart, removing a product from the shopping cart. And assert is whatever the final state is that we want to make sure that the action did the correct work. We looked at how TDD works. Here we have the 3 rules of TDD. Rule number 1, we only write production code to make a failing unit test pass. This implies that we have to have a failing unit test first. i.e. we don't write any production code or implementation code until we've got a failing unit test. Rule number 2 specified how much of a unit test we're allowed to write. Only enough of a unit test to make the test fail, which means we extend our unit tests little by little, just a little bit of extra behavior, just enough to make the unit test fail. For example, when we were testing for an exception, we only tested that we got the exception, not what the exception message was. That was the next step that we did. Okay, so we just do just enough of a unit test to make the test fail. And then number 3 is we write just enough production code to make the failing unit test pass. And that meant at times we were just using a constant, a string literal or a particular quantity, that was hard coded like a 3 or something like that. Okay, so just enough production code to make the failing unit test pass. That's all we did. Then we learned about red, green, refactor. This is our iterative loop that is part of our TDD process. Each of these loops takes on the order of tens of seconds to maybe a few minutes. So we write our red failing test first. Then we move on to making the red test pass by writing just enough implementation or production code. And then step number 3, which is a really important step, is the refactoring of our implementation code to make it easy to read, to make it easy to understand, and also our test code. We want the same properties for our test code as we do for our implementation code. We want our tests to be really easy to read, easy to understand, easy to reuse some parts of the unit test code. And then we close the loop by moving back onto a red state. So we either write a new unit test that's now failing, or we extend our existing unit test with a little bit of more behavior. Next, we touched on the thorns and the gold. And we want to get to the gold, but we need to get through the thorns. What were the thorns and what were the gold? The gold are the happy pass scenarios. We discovered that going for the happy pass scenarios first is a big mistake. It tends to leave our system in a state where exceptions can occur in an uncontrolled fashion. By covering off thorns first, we end up with a more deterministic scenario. First, we want to write unit tests that tease out any supporting data we might need. For example, if we're really wanting to write unit tests that bring out a certain tax amount, we might need unit tests first to ensure that we've got a public tax rate property so we can even work out the tax amount. Next are degenerate conditions. Degenerate conditions are the simplistic states of boundary conditions. And we had that with our shopping cart. We wanted to make sure that our empty shopping cart behaved in the right way. We didn't have any shopping cart items in the cart. It was in fact empty. And that the total property, the total amount, ended up being 0. It would be weird for the total amount to be a non-zero amount for an empty shopping cart. The last thorn are exception scenarios. These are error conditions. We had that with our shopping cart when we were writing the add method. Here, a 0 or a negative quantity were deemed invalid. it doesn't really make sense for most shopping carts to have zero or negative quantities. So we dealt with it and we threw an exception. Exception scenarios are really important for us to cover off, because if we don't, it will mean that we will have a system that can only gracefully handle happy path scenarios. These are very fragile and unstable systems. Anytime, and this happens often in systems, anytime some invalid data comes into it, it will move into a state that is non-deterministic. We're not quite sure what is going to happen. We don't want to end up in a state like this. And we found with these exception scenarios that because we're working in such a small scope, like the add method, that really we only had 2 or 3 types of error conditions. In our case, it was a zero or negative quantity. These were invalid quantities. And furthermore, when the product object that kind of came in, when that didn't exist, so it was like a null product. That was all we had to deal with. That's our universe of exceptions at that small kind of scope. Our unit tests should only ever verify one thing. What does one thing mean? It means one particular aspect of the functionality. So for example, when we wanted to assert that a particular exception was thrown, yes, that's fine. But we wouldn't also, for example, want to verify that the total in the shopping cart is 0. These two would test 2 different behaviors. However, it is perfectly consistent with the one thing to test for the exception, and furthermore that the exception has a particular exception message, a certain error message. That's still part of the exception. So that would still be one thing. A little bit of a tricky point, something to look out for. When our tests test for one thing, it means that we can give them great names. When our tests check for 5 things, how would we name these? Much more difficult. So best avoid it. A unit test should only verify one thing. Also, we learned that as the tests get more specific, the code becomes more generic. And we found that out as we started on the happy path scenario for our shopping cart add method. Initially, we had a very specific unit test that added 3 apples. We wrote our implementation code only for 3 apples because that was the minimum and the most specific that we needed to do. However, as we then also added 5 bananas and 11 cantaloupes, we then found that this implementation code that manages 3 apples could no longer manage 5 bananas and 11 cantaloupes, and we needed to make our implementation code more generic to handle any kind of quantity for any kind of product. And we did that. So as the tests get more specific, the code gets more generic. It's a good one to remember as well.